My name is Swayam Borade.
My name is Asif.
My name is Aditya Borate.
And this is our project gesture control car.
I will tell the apparatus used in our project. So this is the NRF adapter. This is NRF24L01 Plus module. This is MPU6050 module. This is Arduino Nano. The apparatus used in our receiver are Arduino Uno, NRF adapter, NRF24L01 Plus module, and this is the L298N motor driver. And we have used four 5V DC TT motors, and we have used 4 wheels.
I'll give the brief introduction of our project. This is the transmitter circuit. This is the MPU6050 module, which senses the gestures and send that data to the Arduino Nano. Arduino Nano then process the data and send it to the NRF module. The NRF module then transmit the data through radio waves to the receiver circuit here, and this NRF module receives the data and send it to the Arduino Uno, and the Arduino Uno process the received data and send it to the L298N driver module, which in turn signals the motors here to rotate, and the wheel then rotate. And
so this is the transmitter circuit of our gesture control car, which has MPU6050 module as one of its components. It is a 3-axis oscillometer and a gyro sensor. It measures the angular velocity along the X, Y and Z axis using MEMS technology, which has tiny vibrating particles which detect the orientation change in the MPU6050 module. As we move the MPU6050 module, the tiny vibrating elements deflect, and this deflection is measured to determine the rotation rate. Similarly, the MPU6050 module is used to measure the acceleration along the 3-axis.
I'll explain the pin connections. So the MPU6050 module gets power from Arduino Nano using VCC and ground. This black one is the SCL pin, which is serial clock pin. Is connected to A5 of the Arduino Nano, and SDA, which is serial data pin, is connected to A4 of the Arduino Nano. This is the NRF adapter, which acts as bridge between Arduino Nano and NRF24L01 Plus module. The Arduino Nano collects data of rotation from MPU6050 and process it according to the code deployed in it, and send that processed data to the NRF adapter, which is then transmitted to the receiver side of the car using NRF24L01 Plus module wirelessly. And these power pins and this pin, all these pin connections are according to this table.
Now I'll explain the code of transmitter. Here are the X and Y angles which are received from MPU6050 module and mapped to the values ranging from 0 to 254. In this mapping, 0 signifies minus 90 and 254 signifies plus 90 degrees.
So this is our main car. So this is our NRF24L01 Plus receiver module, which takes the data wirelessly from the transmitter module and gives it to the Arduino, which then processes the data, and accordingly the car moves.
So this is the L298 driver module. These 4 are the out pins. These 2 of the out pins are controlling this pair of wheels, and these 2 of the out pins are controlling this pair of wheels. This is the NRF adapter, which is getting power from Arduino Uno using VCC and ground, and the other pin connections are according to this table. And the Arduino signals L298 driver module according to the hand gestures made on the transmitter side of the circuit, whether to drive which part of the motors. And the INT1 and INT2 pins are controlling these 2 of the motors, and INT3 and 4 pins are controlling these 2 of the motors.
Now we will check whether our MPU6050 connection is successful or not. So as you can see, as I move the MPU6050 module, the values are changing. So these are the mapped values which change according to the angle of MPU6050. So this is our receiver code. So the X and Y values which are obtained from the transmitter are again mapped from minus 255 to 255. So the X values, when the X values are negative, these 2 motors will stop and these 2 motors will run. So the car will take right turn. And when the X values are positive, these 2 motors will move, and these 2 motors will be stopped. So the car will turn left. And when the Y values are positive, the car will move ahead, and when the Y values are negative, the car will move back.
We will demonstrate the practical model of the